Well, happy Friday to all, and you too, Toby. And we're on our ways into word problems in our quadratics, and we're going to do some simple ones today, so that should be easy to translate. That's the whole idea, is to get the translation and then do the math that we've been doing up to this point. But before we do that, I'm going to go quickly through the quadratic equation problems that we had for this past time. And most of you did this on the wonderful world of Delta, which is fine, but this is what it should look like. You should get into the habit of doing this practice, okay? And when you're doing it, the ones that did send me papers, I did see some mistakes in there because you weren't doing all the steps. Once again, identify your A, your B, and your C, and then make sure when you're plugging it in, you plug it in properly. The 5 goes in for wherever the B goes, the -1 where the A goes, and then the 7 for the C. All right, and then you should always do this first. Okay, once again, that is called the discriminant. Discriminant, okay. And the discriminant is what goes underneath the radical. And it actually tells you a story, though you'll learn more about that next year. But since this is positive, that means that we're going to have 2 roots. And since it's not a perfect square, that means that they're going to be irrational roots. So we're going to have 2 irrational roots, and if you plug that in your calculator, there you go. Now, if you wanted to double check that, you could type this into your calculator and check the graph on that. We're going to do that real quick just so you see how to do that one more time. And we're going to do a graph and enter. And if I do my negative x squared plus 5x, and then plus 7, and I hit enter, you can see that it's a frowny for starters, and that it goes through at a little bit more than -1 and a little bit more than +6. If you want to get the particulars on it, once again, you menu, and then use 6 to analyze your graph, and then you use number 1, which is your zeros, and you click, and you drag past, and you click. And it's kind of hard to see there with that, but it does say -1.14005, which means we round it to the nearest hundredth. That's my -1.14. Okay, the second one winds up with nice answers. Once again, I gave you some that had nice answers just so you get the practice in. And I had some people that stopped here. Well, that's, you need to do that math. 1 plus 7 gives you 8. 8 over 6 reduces to 4 over 3. And then 1 minus 7 gives you -6 over 6, gives you -1. Okay? And then sliding on down, we got all kinds of craziness going on here. Once again, you have that A is a fraction, so you put it there. So this turns into a 1. So you can just eliminate that fraction. So this would be our exact answer. And if you plug that into your calculator, it will look like this. I had a couple of you that, interestingly enough, simplified this radical, which is something we've never done before. So either you have a math teacher for a close personal friend, and or you have a TI-30 calculator and typed it into that, or you have somebody like an older sibling that is doing Algebra 2, which is something that we're going to be doing possibly later on this unit, next unit actually. And on the back side, I got you some answers so you can check your stuff. But that's what you got going on there. Once again, just be careful about your substitutions. And once again, you can only have sometimes one solution. And actually what they say about this is that there's 2 solutions and they're the same, which sounds kind of redundant to me, but anyway, that's what we got going on there. So now we're going to head over to page 59. And I'm going to demonstrate some word problems, and your homework will be some word problems, both Delta deal and on the pages here. And we just need to go through and identify what we have going on. All right, so it says the square of a number decreased by 14 times the number is equal to -24. And you just want to do some translation. So the first thing I say, the square of a number. So this is x. So x, remember we have our let statements just to identify things. X equals a number. Now, if they told you the square of a number y, then you'd use y. But this is just going to be the number. This is a really simple problem. So it's just going to be a number, all right? And sometimes we're going to find out that you can only use a positive number or a negative number. If we have to do that, we'll figure out how to do that momentarily. And it says we're going to square it, so that gives me x squared. And hopefully by now we know decrease means subtract. And then it says 14 times the number. There's another x. So 14x is equal to negative 24. All right, so from here we need to solve this. Now, I would tell you that 99% of the time when they give you a word problem like this, you're not going to have to use the quadratic formula. You're not going to have to complete the square. It should factor for us. So if it's going to factor, we set it equal to 0 by adding the 24 to the other side. Remember when things cross over the equal sign, remember we got our little dividing line there, that they change signs. So a negative 24 becomes a positive 24. So I get x squared minus 14x plus 24 equals 0. And now we're going to do story time. And our story time, this tells me that signs are the same. And this tells me they're both minus. So I'm going to go over here and I'm going to do x minus and x minus. Don't forget your equals 0. All right. And we need to find the factors of 24 that add to negative 14. And they're both negative. So your factors of 24, once again, you could use your calculator to find this. And the procedure is in the previous units package. Actually, it's on that worksheet of factoring trinomials. And that would be negative 1 and negative 24, negative 2 and negative 12, negative 3 and negative 8, negative 4 and negative 6. Those would be all the negative factors of positive 24, and this is the one we're looking for. So 2 and 12. And when you're doing this, you have to do the t-chart and find out what those factors are equal to. X minus 2 equals 0, x minus 12 equals 0. Add them over. Final answers are x equals 2 or x equals 12. Technically, you should put them in the squirrely brackets, so x equals squirrely bracket 2 comma 12. All right, nothing particularly special going on there, but that's what we got. All right, so the next one, once again, pretty straightforward. Not a lot going on here as far as words, not real complicated. Just looking for a translation into an equation and then solving that equation by factoring. So once again, I get x equals the number. All right, and there's an x there. I got an x there. And it says we're squaring that number, so I get x squared. Once again, we're decreasing it. Minus 48, no x there, is equal to twice the number, 2x. Okay, remember when you have twice a number, you're multiplying. So now we need to get the set equal to 0. So I'm going to subtract the 2x over. I should put this in standard form, which means I have the x squared minus the 2x minus 48 is equal to 0. And my story time on this one, this tells me I have a plus and a minus. This tells me the bigger one is a minus. And do the same thing, slide it off to the side. So I have parenthesis x minus and x plus equals 0. And I need the factors of 48 that have a difference of 2. And if you went through the whole process, we know that 6 times 8 is equal to 48. And 6 minus 8 equals negative 2. I'm going to do minus 8 plus 6. T-chart. X minus 8 equals 0. X plus 6 equals 0. Add and subtract to move them across. So I add 8. Subtract 6. X equals 8. X equals negative 6. Now, you could do some checking on this. If you did some checking, you could type this in as your first equation and this in as your second equation and find out where they meet. You'd have to expand your stuff, but you could do that. And we'll do that later. All right, and then it says the square of a number decreased by 42 is equal to the number. All right, Same basic type thing, the square of a number, so x equals the number. I get x squared decreased by 42 minus 42, lots of subtraction here today, is equal to the number, equals x. This is almost exactly like what we just did up here. The number's slightly different. We just need to move the x over. And that gives me x squared minus x minus 42 equals 0. And this one tends to confuse people. You got to remember you have that magical mystery invisible 1. So we're looking for the factors of negative 42 that add to negative 1. And that's going to be x minus 7 and x plus 6. And then just to t-chart it, and that flips your sign, so you get x equals 7, x equals negative 6. No basic things, just looking at your things. It's not a bad idea to do what we did up here and right over the thing. So I got my x, I got my squared, I got a decreased, 42 equals x. It's a good habit to be in. Use some highlighters, use some pencils in order to get good translations. All right, I'm going to do a couple more, and your homework will mirror these, so you should be able to do these pretty straightforwardly if you keep your videos nearby. And all right, and these are classics. All right, so here it says the face of a box must be made so it is exactly 54 square inches, and it says the length of the box should be 3 inches more than the width. So we're looking for our unknown. Whatever they say second is going to be our x. It gives me an x, so x equals the width. Now, you could say that y equals the length, but then you'd have to find something to substitute in there. But watch what I can do here. The length is right here, 3 more than the width. So x plus 3 equals the length. It's not really worth it to use two different variables on this, because then you just wind up doing a substitution. Now, the next thing we need to know is the area of the face of the box, right? So we're looking for an area, and we know that area equals length times width. At least we should. And that means that the area is equal to x plus 3 times x. But they told us the area, so that's going to be equal to 54. I've got another step on this. First thing we need to do is distribute. That gives me x squared plus 3x equals 54. I subtract the 54 over. X squared plus 3x minus 54 equals 0. And we go to story time. This tells me I have a plus and a minus. This tells me the bigger one is a plus. I'm going to have two sets of parentheses. Equals 0, x plus, x minus. So now I need to find two numbers that multiply to negative 54. So we're multiplying the negative 54. We're going to add the positive 3. And if we do that, and we go through that process, we're going to find out that it's going to be plus 9 and minus 6. I t-chart, and it does the sign flip, and I get x equals negative 9 and x equals 6. Now this is super important. All right, you have to do this. If you skip this step, it's going to be a mandatory deduction. This right here, it's impossible. You cannot have the side of your box being negative 9 inches long. So therefore, you have to write the word reject. You reject the negative in real world situations. This is only real world. Okay, if they're talking about a garden, they're talking about a box, they're talking about a patio, it has to be a positive number. All right, so that means that this is the good number. All right, and you have to tell me both numbers though. So you have a 6 here for the width, and then you add that 3 to it. 6 plus 3 is 9. So a lot of times that rejected number will wind up being the other number with the sign change. Not always, but a lot of times. All right, so we have a 6 by 9 box. 6 by 9 is 54, and that works out just fine. All right, next one. We're on page 60, problem number 5, and we're looking at the length of a square is represented by 3x. Now, they didn't tell us anything on this, and I probably should have done it up here as well. I probably should have drawn a picture. Let me add that picture to it now. And it's x, and then x plus 3, and then the area is 54. So it was a good idea. So on this one, it says the length of a side of a square is represented by 3x, and the area is 144. Well, draw myself a picture. This is 3x. Once again, it's a square, so this is 3x. And the area of a square is side squared, so the area is equal to side squared. So that means 144 is equal to, now watch when I do this, parenthesis 3x close parenthesis squared. Very important that you remember that, okay? Otherwise you're going to wind up with some bad numbers. All right, so when I simplify this, that gives me 144 is equal to 9x squared. I'm going to show you 2 different ways to solve this. All right, the first one is by factoring, and the second one is going to be a slight cheat. All right, so I'm going to bring over the 144. I get 0 equals 9x squared minus 144. Now, one of the rules that we had whenever we were going to do factoring was that you were always supposed to look for a GCF first. Now, you may not realize it, but there is a GCF here, and the GCF is going to be 9. So basically, when you have a GCF and you have an equal sign and it's a number, you can basically divide through. So if I divide everything by 9, I get 0 equals x squared minus 16. Now, when you have something like that, you can factor it using dots. I'm going to bring it up here. We're going to do dots. Difference of 2 squares, in case you don't remember what that is. 2 sets of parentheses, and they're equal to 0. 0 could be on this side or that side, doesn't matter. And you take the square root of the first term, so x and x. And the square root of the second term, 4 and 4. One gets a plus, one gets a minus. Then you t-chart, flip sign, y equals -4, or x equals -4, and x equals 4. You got to reject the negative, and that means that x equals 4. And if you think about it, 4 times 3 is 12. 12 times 12 would give you 144. Okay, so the other way of doing this problem, all right, and since it's a real world problem, you don't have to worry about that positive negative thing, is once you get here, you could have taken the 144 equals 9x squared. You could have divided by 9. 16 equals x squared, and then square rooted. And x equals technically plus or minus 4, but then you still need to reject the negative, so you still wind up with the same answers. This is perfectly legit work, or factoring it this way would be perfectly fine. Either one's acceptable. You just got to pick one and work it to the end. Okay. Now here, well, look at that. Lots of words there. This is one of your classics. This is what they do all the time. Now, obviously, you're not taking a Regents this year, but you'll see it next year at some point. Somewhere along the line, I think you're going to see problems that look something like this. All right, so here's our once upon a time story. The length of a rectangular garden. Okay, so first thing I'm going to do is draw a rectangle. And it says that the length is 2 less than the width. So this is going to be our x. That's our width. And then it's 2 less than for that, so x minus 2. And you're saying, well, Mr. Douglas, if that's less than, how come it's longer? It doesn't matter. We're just basically using the shape so we have some sort of reference. Then it says, oh, here we go, if The length of the garden, length is increased by 4. Okay, so we're going to take this. We're getting ourselves a new garden. Okay, and I'm going to add 4. So -2 plus 4 gives me x plus 2. And then, oh, this is nasty. And the width is multiplied by 2. So we're going to take this, and we're going to do times 2, so that gives me 2x. The area of the new garden is 48. Lots of nastiness going on here. But once again, you start with a shape here, you make the changes that they tell you to make, and now you have your new shape. And when you find that, what you're trying to find out is what these 2 dimensions are here, and that's what we're going to find out when we're done. All right, so we're going to take this, and we're going to set it up as an area problem. So we know that length times width equals area. That means that x plus 2 times 2x is equal to 48. I'm going to distribute this in, because I share because I care. And that gives me 2x squared. Remember, x times x is x squared, plus 4x equals 48. I subtract the 48 over. And that gives me 2x squared plus 4x minus 48 equals 0. And you're saying, okay, now I got to factor that, and that's one of those where the a isn't equal to 1. Oh, that's horrible, Mr. Douglas, blah, blah, blah. Well, once again, GCF first. And since we've got it equal to 0, we can divide everything by 2. And that gives me x squared plus 2x minus 24 equals 0. And I can factor this into x plus and x minus. And difference of 2 that multiply to 24 are going to be 6 and 4. And I t-chart. X plus 6 equals 0, so x equals -6, that's a reject. And then x minus 4 equals 0, so x equals 4. That's my happy face. And then I got to go back up here, so if this equals 4, then this one is equal to 4 minus 2, so that's going to equal 2. So my original garden was 2 foot by 4 foot, which is kind of weird. And my new one, if they ask you for that, and you got to be careful, sometimes they don't ask for the size of the original garden, they'll ask for the dimensions of the new garden. And if we did that, that would be 8, and then that would be by 6. So 8 times 6 is 48, so yay us. We got it down. So those are 6 problems that you have. Your homework is those next 2 pages, 61 and 62, and I believe that there is a Delta assignment that will work with that. So ready, set, go. And this will be due for Tuesday, and on Tuesday we will be doing the intersection of a line and a parabola.